Right, hello folks, and welcome to your next lesson in the electricity unit of study, which is on energy transfers. So as you'll see, as usual, we've got a bit of specification information, just giving a summary of some of the key points we're going to try and cover today. If you start for me, please, by having a look at the knowledge check questions, some of which are true and false, and some of which are just recall questions. So if you can pause the video now and have a go at those for me, please. Right, if you've unpaused the video, you will have had a go at the knowledge check questions. So let's go through the answers nice and quickly. The unit of power is the watt. True, the unit of resistance is the volt. False, it's the ohms. The unit of current is the amperes. True, or amp for short. We call the equation for power P equals I times V, power equals current times voltage. We call the equation for power in a resistor. So what's the alternative version to that equation? Power equals current squared times resistance. We call the equation for potential difference. This is also Ohm's law. V equals IR. We call the equation for charge. Q equals current I times T time. And then how do you calculate the total resistance in a series circuit? Add up the resistances of the individual resistors. Right, let's have a little bit of a look at some context for this lesson. So let's go through this paragraph together. Energy transfers in everyday devices. A kettle is designed to bring about an energy transfer. So remember, it's when stores of energy change from one form to another, gravitational to kinetic, electrical to thermal, etc. The chemical energy from the fuel in the power station is transferred via the electrical pathway to the heating element in the kettle, increasing its thermal store. Some kettles will boil the water faster than others. The more power an appliance has, the faster it uses energy, because remember, power is how quickly it transfers energy from one store to another per second. So if it's using more power, it's transferring energy quicker from one store to another per second. For an appliance, the energy supplied to it depends on how long the appliance is switched on for and the power of the appliance. So remember, the PD, also the potential difference of the main supply, causes the charge, which is carried by the electrons, which flows through the appliance. Okay? So that's important to remember. Now, we have an equation that we have to be familiar with for calculating energy transfers in electrical everyday devices. And that is energy transferred equals power times time, or E equals P times T. Now, energy is in joules, power is in watts, and time is always in seconds. So make a note in your annotations that always convert to these units. And as it says in our checkpoint question, E equals P times T. Energy is in joules, power is in watts, time is in seconds. You also need to be familiar with rearranging the equation. So not just being able to calculate energy transferred equals power times time. Power equals energy transferred divided by time. And time equals energy transferred divided by power. Worth writing those out if needs be. Right. Let's have a little look at applying these initially. So to begin with, we've got an equation here. Energy transferred equals power times time. So in this column, we don't know energy, but we do know T, and we do know P. So have a go for me quickly. And all we're doing is we're timesing these together to get our energy transferred. So pause and have a go for me. Right, if you've unpaused, that means you've had a go at these. So you should see that our answers are as follows, because we're following the same pattern for each of these. 1 times 2 equals that, equals that. So remember, power times time equals energy transferred. But we also have to be able to use the equations when they have been rearranged. So, have a go for me, just making sure you've got them written down in word format as well as symbols. Power equals energy transferred divided by time. And time equals energy transferred divided by power. Right, so we're left with some equations on the next page. Now, as you'll see, they are blanked out. What I'd like you to do now is use these two equations where appropriate, and actually these three equations even, because you might need to use the original of energy transferred equals power times time to work out the answers that are missing, okay? So pause the video for me now and have a go at using those equations to try and work them out. Right, so if you've unpaused the video, that means you've had a go at these questions. So let's just go through them quickly. Energy transferred divided by time. 10 divided by 800 equals 0.0125. Energy transferred divided by time. 60 divided by 5,100, 0.0118. What is time? Time is energy transferred divided by power. So 30 divided by 1500, 0.02. 900 divided by 1450, 0.062. And then power times time gives you energy transferred. 218 times 54,500 and 1,500 times 210. So mark them, see how many you got right, and correct them if you need to. Right, let's have a look at some examples of some higher level questions. So, have a look at these two questions for me now. And because these might be a little bit more challenging, I've given you some clues. So a lamp in a circuit is a potential difference of 12 volts across its terminals when the current through the lamp is 2 amps. Calculate the electrical energy supplied to the lamp in 300 seconds. So you need two equations here. P equals I times V, and energy equals power times time. Can you use the figures that I've highlighted there and the equation hints that I've given you there to work them out? Also, the second one, a 50 ohm resistor in a circuit has a charge of 4 coulombs passing through it in 20 seconds. Calculate the potential difference across the resistor. So again, I've given you two equations that you might need here. First, you need to work out I, then you need to put it into V equals IR to work out the voltage. And the electrical energy supplied to the resistors in 20 seconds. So again, you need these two equations, and you'll need to be using information from previous questions. So, pause the video and see if you can have a go at those, and then we'll work through these answers together, okay? Right, hopefully you've had a go, and if you want to pause the video, we can work through some answers. So, P equals I times V. So, we should have spotted that our current is 2, and our voltage is 12, which would give us 24 watts. E equals P divided by T, so we've now got a power, 24, and what's our time? It's 300, so P times T, 24 times 300, give us 7,200. Now, energy, what is energy measured in? Energy is measured in joules. So, correct any work you got wrong, or just make sure you've got the notes in there as required. Then a 50 ohm resistor in a circuit has a charge of 4 coulombs passing through in 20 seconds. What's the potential difference? So, current equals Q divided by T. So remember, this is our Q, and this is our T. 4 divided by 20, 0.2. And if it's current, it's amps. Now, V equals IR. So we've got a current. What's our resistance? 50. So we times them together. Equal 10. And because it's V, it needs to be voltage. And then, lastly, P equals IV. So what is our I? What's our current from the previous question? It's 0.2. What's our V from the previous question? We've just calculated it. 10. Which gives us 2 watts. So energy transferred equals P divided by T. So the electrical energy supplied across the resistor in 20 seconds. So we need the power. We've just got it 2. And now we've got our time. Times it 2 times 20. That then gives us 40. And because it's energy, what's the unit going to be? It's going to be joules. Good. Let's have a look at another one together. Right. Again, I've given you some clues on this one, so let's just talk through the first bit, and then you can have a go at yourself, and then we'll go over it again. So a 12-volt battery is connected to a lamp in series with a resistor and an ammeter. Lamp, resistor, ammeter, voltmeter. Voltmeter is connected across the lamp as shown. The ammeter is reading 2.5 amps and the voltmeter is reading 9 volts. 50 coulombs of charge flows for 20 seconds. What is the electrical energy supplied by the battery in 20 seconds? So remember, electrical energy unit is joules. P equals IV and E equals P times T. So power equals current times voltage. Got a current. And we've got a voltage. Just remember, it's supplied by the battery. Okay? So 2.5 times 12 give us 30 watts. So we've got our energy transfer that we need to calculate. We've now got our power, 30. But what is it over in terms of T? What's T? Our time is 20 seconds. Times them. So give us 600 joules. Now, show that 450 joules of energy is supplied to the lamp in 20 seconds. Okay, so let's go back to these again. We've got the same 2 equations. Power equals current times voltage. So let's go back to our question. Now, the voltmeter reading is 9 volts. So it's showing you the voltage across the lamp. The voltage across the lamp. So we've now got our V. What is our current? We've done this already. This is the same on series. So it becomes 2.5 times 9. It's 22.5. It's power, so it's watts. We've now got our power. So we can do 22.5. And over how many seconds? It's 20. So 22.5 times 20 equals 450 joules, which, as you'll see, is the same as what was in the question. And then calculate the electrical energy supplied to the resistor in 20 seconds. Okay, energy to the resistor. So if you think about it a little bit like this. What's the starting energy supplied by the battery? Got that already. It's up here. 600 joules. What's the energy used by the lamp? We've just done that. That's 450. So if the energy by the lamp's been used up, we started with 600, what have we got left? So we do 600 minus 450, sorry. 150 joules. So a couple of more complex but worthwhile examples, making sure that you've gone through and understood to the best of your ability. Right, we'll move on now to our second equation for the day. Energy transfer and charge. So if you read through this with us together, as electrons flow around a circuit, we know that electrons flowing around a circuit is described as current. They gain potential energy in the battery and lose it in the components. So that's our energy transfer. Now, the amount of energy depends on the potential difference or the voltage. 1 volt is defined as the potential difference between 2 points if 1 joule of energy is transferred when coulomb of charge flows between 2 points. That's quite confusing. So, simplify it again. When we are talking about the power of a device, it's related to 2 things. The voltage across it, potential difference, and the current through it. And also how much energy is transferred over a given time. Okay? So, as the charge flows through a component circuit, it transfers 3 joules of energy to the components. Therefore, the amount of energy transferred by electrical work can also be calculated using this equation. So this is our key bit. Energy transferred equals charge times potential difference, or E equals Q times V. So charge, we also know we can work as current times time, because if you remember, Q equals IT. Make a note of that for later, because that's a part that will come into it. We also need to be sure that we can rearrange these equations. So rather than E equals Q times V, Q can also equal E divided by V, and V can also equal E divided by Q. So we've got some notes there to add. Now, let's have a look at some examples. So, as I said, we need to know the equation. We need to know that energy is joules, charge is coulombs, and potential difference is volts. And make a note of the rearrangements. Charge equals energy transferred divided by voltage, and voltage equals energy transferred divided by charge. So, if we've got our equation here, remember, E also equals Q times V. So, this is our E, this is our Q, and this is our V. So, pause the video for a moment, and remember to work out energy transferred. Oh, disappeared, sorry. Times those two to get your answer. Times to get your answer. Times to get your answer. Pause the video and work them out for me now, please. Right, if you've paused the video, you should see that energy transferred is 150 times 9, 1350. 15 times 3 is 45, and 150 times 1.5 is 225. Let's have a look at some questions together then, because we don't want to get too confused by this. So a 6-volt battery passes a current of 1 amp through a lamp for 1 minute. How much energy is transferred from the battery to the lamp? So, E equals PT. And since P equals IV, E equals what? Now, can we replace any of these bits of information? Energy equals power times time. We know that power equals current times voltage. So we can also know that energy equals current times voltage times time. We've got a voltage, we've got a current, we've got a time. But what we need to do to this, minutes is not a unit. Convert it to seconds, so that needs to become 60 seconds. So we end up with 1 times 6 times 60. Which gives us 360, and if it is energy, it's in joules. How much energy is transferred when the potential difference is 120 volts and charge is 2? We've got a V, we've got a Q. So according to this, what do we need to do with them? Times them together. So E equals 120 times 2 gives 240, and it's energy. So it would be joules. How much energy is transformed from potential difference of 150 volts, 5 coulombs of charge? We want to know E. We've got a Q. We've got a V. What do we do with those two numbers? Yep, that's right. Times them together. Should equal 750 joules. As you'll see, answer there is the same. And then it requires 600 joules of energy to transfer a quantity of charge between point C and D of the circuit, which has a potential difference of 30 volts. How much charge is transferred? So we don't know Q, but we do know E, and we do know V. So energy equals Q times V, charge times voltage. So Q, charge, equals energy divided by voltage. So our energy, 600. Our voltage, 30. Divide them by 20. And because it's charge, what is charge measured in? It's measured in coulombs. Right. Pause it there for me now. Now, there's two options here. You can, in a moment, have a look, if you're comfortable with this, at some of the higher level questions here. But before you do that, can you now find yourself some spare paper or notes page or anything like that? And I want you to have a look at these questions for me. So there are a lot of questions here. Have a go at as many as you can. Remember two important things. Convert your units. Convert your units. You need power in watts, energy in joules, time in seconds. So convert units to these. And remember your two equations. So you need either energy transferred equals power times time, or you need energy transferred equals charge times potential difference. Don't forget, you might need to rearrange equations. So look at what it is the question is asking you to calculate and see whether you can use it in these forms or whether you need to rearrange it to one of our other rearrangements that we've written down. So pause the video now and have a go at as many of these as you can. Once you've done, I'll show the answers and then you can go on to your final section. Right. Hopefully you've had a go and done as many as you can. Got them on a spare bit of paper, got them on a notes page. Now, have a look for me at the answers. Pause the video and go through and mark and correct any of your answers. Now, I don't think question 4 is on there, so you've got 5 different questions to be having a go at. Mark them, and then if there's anything you're drastically stuck at, do not worry, just drop it in an email to your teacher and they'll be able to help you out, okay? So if you pause that screen for the answer, great. Once you've done that, unpause, and we'll go back to the final section here. So if you want to have a go at any of the higher level questions there, please do pause the video and have a go. And as you'll see, I'll just reveal the answers for you. So if there's anything there you're unsure about, do drop an email to your teacher. And then to finish, I've got the knowledge check questions to finish. So pause the page, have a go at the questions, and then review the answers. Right, just to give you your final set of answers, mark them and correct them as you require. Don't forget at the end of the page as well, if you need any extra support, there's the summary videos that are in the description below that you can watch and just make any notes on, just to make sure you're happy with this, and do feel free to drop your teacher